Okay, so continuing in our lesson on confidence intervals, we've just gone through examples of the z-interval for the mean, the t-interval for the mean, and the proportion interval. Now, the calculations for those are pretty simple in StatCrunch. The harder part is figuring out which one to use in a given scenario. So let's focus on that now. So there's really two questions you need to ask yourself. The first one is, are we looking at the mean or the proportion? So if it's for the mean, we've got two choices. For the mean, it could be the z-interval or the t-interval. Or if it's the proportion, that tells us right away there's only one for the proportion. So when we read the problem, we need to ask ourselves first, is it for the mean or the proportion? So for the proportion, you might see words like proportion, rate, percent. You can rephrase your data as x out of n. That's a dead giveaway. Or some percent out of n. If you see that, then it's a confidence interval for the proportion. And to do that, as we've looked at before, you'd go over to stat, proportion stats, one sample with summary. Okay? So that's if it's for the proportion. If it's for the mean, you're either going to be given a list of data, like we were in this problem. We're given a list of data, or given a mean and a standard deviation and a sample size, like we were in these other problems for the mean. So if it's for the mean, then you have to ask yourself one other question. And that is the standard deviation for the population known? So here are some clues that the standard deviation is for the population. It might say sigma equals. It might say the population standard deviation is, or is assumed to be. And it might say from previous studies the standard deviation is known to be. That means it's an estimate, but it's based on that we think we know what the population standard deviation is. Okay, so if the population standard deviation is given, you use the z-interval. Otherwise, it's the sample standard deviation, and you'll use the t-interval. So clues for that, they might say S equals. The sample standard deviation is. This one here is very, very common. The mean of the sample is, and they'll give you a number, with a standard deviation of. And what this tells you is that the mean and the standard deviation are both calculated based on the sample. Finally, the standard deviation might not be given, like we saw in the example with the data, but must instead be calculated from a list of data. Okay, and for that you would go just like we did with this one. If it's a z, we go to one sample with summary. If it's a t, one sample with summary or with data. All right, so let's go through some examples here where all we're going to do is pick out which formula to use. All right, so in this one, they tell you we've got a random sample of 30 households. The average usage was found to be 375 kilowatt hours. Assuming the population standard deviation is this, calculate a confidence interval and interpret it. So here we know it's for the mean because they're telling you the mean and the standard deviation. It's not a proportion. So it's for the mean, and then we have to figure out is sigma known. This says the population standard deviation. That means sigma, the population standard deviation, is known. Therefore, this one's going to be a z confidence interval. And so we would go into StatCrunch and calculate that as a z. In this one, a survey of 250 registered voters, 120 said they'd be likely to vote in an election for city council. This one is going to be a proportion. 2 clues here. One says calculate a 95% confidence interval for the proportion. That's our dead giveaway there. Also, we can phrase our data as 120 out of 250. So that's x out of n. So that tells us we're going to use the proportion. Our third example, in a sample of 40 preteens, the average score was 18.9 with a standard deviation of 3.2. We know this has to be for the mean. Just going through our 2 questions, we know this has to be for the mean because it tells you the mean and the standard deviation. It's not for the proportion. And then to decide whether it's a z or a t, the way this sentence is phrased, you can see that the standard deviation comes from this sample of 40. Therefore, that's the sample standard deviation, so this one's going to be a t confidence interval. All right, so that's it for this lesson. And as always, let me know if you have any questions.